Good afternoon, course participants. The first lecture is Introduction to GIS that I will talk. So overall, if you see this module, it is also important module as part of the total program. So there will be around 18, 19 lectures are there in this. In that, including demonstration on GIS softwares, and then analysis and then data entry, all those things are discussed as part of this. We also have some lectures and demonstration on Bhuvan portal, how to use Bhuvan portal, how to update the, upload the information and spatial information onto the Bhuvan portal. So, and then if you see this as part of the total program, that is the basics of remote sensing, GIS, GNSS and applications. So this is a very important component in that. If you see that various technological components, one is remote sensing, another is GNSS, the third is GIS. You might have understood what is the remote sensing. So there basically what we do is we acquire the information. Suppose if you see the satellite image and somebody asks you to delineate water bodies, delineate road information, or some forest area, etc. So that means remote sensing will help basically acquire the information. So though it is required that you should have a basic understanding how the remote sensing data looks, what are the spectral signatures for different features and how to identify. So that's why if you talk about identifying groundwaters or groundwater assessment is not a GIS component. It is more of a remote sensing component. Now suppose you wanted to monitor the groundwater, what are the fluctuations happening in the groundwater. For that, suppose you collect the data from the ground, like what is the level data, suppose level of the water in the different wells, and then you see that how the level is varying at different time period, and then what are the total volume content, how this water is fluctuating, whether it is decreasing during summer season because we extract more water, and then increasing during rainfall because a lot of rainfall is happening, so that how much is water is accumulated. So these type of volume increase and then finding out the profile of this groundwater levels, so that comes under a GIS. But whereas if you wanted to identify prospective zones using satellite data, so that is a remote sensing component. And then another component is, suppose where all these wells are located. Suppose if you use a GNSS instrument and then record those location information and then bring it onto your maps, and then on the map using GPS you identified the locations, and then using the ground information you also identify the levels of the information. Suppose you wanted to interpolate groundwater level of that wells, so and then generate a three-dimensional information, so that is used through the interpolation techniques. So like that, different technologies are used for different type of applications. So now what I am going to do is I will just give an overview of GIS. Now what is GIS? What GIS can do for us? Suppose, as I mentioned, remote sensing means you acquire information spatially for anywhere on the earth using the satellite images. Similarly, you use GNSS instruments to find out your location information. So the same location information can be also used for navigation purposes. So that is further application of that GNSS. And then as far as GIS is concerned, how GIS is going to help and what are the things what we can get from GIS. So identifying something, suppose identifying the water wells. So that is also, once you create an information, create a database, so extracting from that is comes part of a GIS. So where all these wells are located, how these wells are connected, like what are the distance between the wells, and then how to reach these wells. So these are all comes under a GIS. And then what are the different type of analysis what we can do in a GIS, and different modeling, and then what are the different applications for a GIS, including what are the hardware and software requirement for GIS, and then different type of analysis, and then how this is GIS can be used for different applications. So this I'll give you a overview of all these components in this lecture. So there are I listed out outline of my presentation. One is a general understanding of GIS. I'll give through examples so that it becomes easy for you to understand, and then different concepts of GIS. There are different data models are there, and then different type of analysis how you do, like a single layer analysis, point pattern analysis, multi-layer operations. So these are all comes under different concepts of GIS, and then potential of GIS. What is the potential of GIS? Like if you wanted to find what are the houses in a particular area are submerged in a flooded conditions. So then you use the different techniques of GIS using a different period of data, and then different incorporating population houses data which are already existing. If you generate different layers, so then when you merge together and then see that when the water is flooded to those areas, we can know that how much houses are submerged, how much is the this one cost of those areas, or how much is the damage is happening to those things. Cropped area, if it is a cropped area, how much is the crop area is damaged. So all those things we can use GIS. So it comes under potential of GIS for different applications. And then what are the different type of hardware? Is it the same hardware what we use? You sit nowadays with a computer, laptop, or smartphone, or your high-end computers like workstations, or high performance computing systems. So then what are the systems what exactly you required for GIS, and then what are the different type of softwares? Either it is a proprietary software like CARD software, or it is open source software, or a free software. What is the softwares? And then different type of operations and analysis you require a different type of software. If it is vector type of analysis, there are different type of softwares are there. If it is raster based, there are different type of software. For network analysis, there is a different softwares. So as far as history is concerned, how this GIS is evolved over the years. So for the last, you can say 50 years or so, so GIS has taken growth. So now it has spread to many applications. So compared to that earlier, the remote sensing is started very long back. It was 60, 70 years, but whereas GIS has came later. But if you see the market and then spread of GIS is much more than remote sensing, as far as marketing is also, this market potential is also concerned. So then we'll have a further interaction with all of you, and looking into the different questions. So let us start this general understanding of GIS. So to give an example, suppose you take a map, like a topographical map or a tourist map, wherever you go into the place. So then what you get from that map? Suppose I am looking for the maps because I wanted to go to some place. That means I'm visiting a place. So then I wanted to reach other place. Suppose I came to so maybe Delhi and then railway station, and I want to go to airport or some other place, or India Gate, etc. So then I look on the map and then try to go to that place, and then what are the means of transportation to go there. Then I look into that and then try to reach that place. And then nowadays the maps are also is uploaded to your smartphone. So then you can also use your smartphone as a map reading. So once and then using that, it will also help you to identify what are the different things on that. So, can we measure and quantify something on the map? Yeah, yes, if you wanted to see that how much of the area is occupied a water body, how much of area is some tourist location is there, so then you can also measure and then quantify those things. And then if you wanted to find out the distance between the places, so then you can also using the scale, you can also measure what is the length of the road you have to cover, so to go to that place. So basically, if you have a smartphone, it will also help you to give all this information. But if somebody is carrying a conventional map, so then one has to convert that into actual distance on the ground. And then can you find the optimum path or route? What is optimum path means? Suppose I wanted to go from one place to another place, and then what is the shortest route so that I can reach there in the minimum time possible. So suppose if you are walking, so shortest route is okay, you can walk on a certain route and then reach that place. But if you have a lot of traffic and you are going in a car or in a vehicle and then wanted to reach, so then you have to go in one a particular path. So there may be one way type of moving, so you cannot go these things two ways. So then you have to go along that path you have to go. So that means the optimum path is which direction you have to go, what is the distance to reach that. And then sometimes nowadays in the cities, the radios and other things also they communicate. If you go in a certain route, so your traffic is jam and then it becomes dead slow. Maybe it takes instead of 10 minutes, maybe it take 1 hour to reach other place. So all those informations you can also feed into the GIS, and GIS also can help you to find out that how much time you can reach from one place. One is in a GIS you can create a road information, and that road information you can also add what is the speed of the vehicles if they go on that particular road at a particular time. So all these things once we add it, so then optimum path may be very long if you, but the time taken may be less if they take other alternative route instead of that heavy traffic route. So another way is to look at is it possible to find the changes in a map? See, change means suppose in an urban area, new township have come, or what is the difference between the maybe 5 years back and what is now. So for that, a single map, if you see, it is not possible. And then these maps are also produced once in 15 years or once in 20 years. They are not updated. So that's why if you wanted to find the changes and all, it will be very difficult if you're using the single map. So that means some of the things what you can see from this, you can find out using the map. In a GIS also, we normally create a different layers, and those layers are stored in a GIS environment. All those things what we are discussed. Can we measure something on that? That means you can quantify, identify, and then measure something, and then also find the route and then navigate. So these things you can these are all basically GIS activity, and then now it is also all this information is used as part of smartphones. So that means GIS component is also loaded into the smartphones. That is a part of GIS activity. So that means you can find something, we can also navigate, and then you can also find the optimum route. So these are all related to GIS. So if you see this is a topographic map, and then once you wanted to see that's a particular place, this is uh, Vermont, something place is there. This is part of USA, but this is a map. Suppose you wanted to identify certain place and identify some important place, etc. Using the topographic or any map, whatever is given, tourist map. So then you can use that and find out, and then go from one place to another place. So that way you can use the maps. Another is suppose you talk about a remote sensing. So how this remote sensing is related to GIS? Remote sensing is basically what you get. You get a satellite data, it comes in a digital numbers, and then those digital numbers, what we do is we convert into certain information. It can be a agriculture field, it can be a school location, it can be a road, or it can be a post office. There are a lot of informations are there on the satellite data. So those satellite data, what we do is normally we convert into an information. So that converted information you can store as a one of the layers of a GIS, and then once you create into the GIS, so then that you can use further analysis. So further, once you create an information, create a database, spatial information, and also add attributes to that. So then it will stay as a one of the component of a GIS. So, but information is coming from remote sensing. So what you get from the satellite? All the information, if you use a single data also, you can also use multiple data. So what is the advantage of satellite data when you compare to the maps? Advantage is you can get the latest information. Suppose I wanted to know the information particular about Dehradun, and then you can get a satellite data particular date. Maybe today's date also I can get, or yesterday's date. And if you wanted to know in advance also, you know that particular date the satellite is going to cover the Dehradun, so you can also cover that. So particularly if you wanted to do some crop analysis, crop monitoring, dynamics, etc. So those things are also you can do using a satellite data. So can we find any changes and how? So if you wanted to find the changes, like I have given example of floods, so then we can use two different data sets, before the flood event and then after the flood events. And then you both use that and then create a map with the flood inundant area. And then what are the, when it is inundated, whether it is damaged, human population or houses, or a crop damage. So all these things you can find out. So that means changes can be easily you can find using the GIS. See earlier if you talk about in 1980s when the GIS was not there, even suppose if I have a small map and I created some land use map, this is agriculture area, this is a forest area, this is a water body. So even to know the what is the total area comes under each category. So we used to use planimeters. So that planimeter, even if one map is there, so it used to take a lot of time. There's so much small polygons, and then also some polygons we may miss there also. So then it used to be a Herculean task. So once in a GIS, if you create those things, so it's straight away automatically that information is stored. So you don't require to measure separately. Whatever you digitize, then it will be converted into the area polygons of those things, and then that you can use it directly getting the information. So one is if you wanted to find the changes, you require two different data sets, and then if you wanted to have a pattern means how this city is growing. Suppose if you say 1920, 1950, 1970, 2000, how the city has grown over the time, in which direction the city is growing, what are the reasons for that, and then you can find out the pattern of the growth of the urban city. So similarly, other patterns in other examples also you can think of. So that means if you wanted to find the patterns, we should have a time series data. So that time series data, in case of satellite, that we can get only through the satellite. Can we quantify this information? Yes, when you use the satellite data, and then when you can do it a manual method, or you can do it a automatic extraction information, so that you can quantify that information. So all these things, as I mentioned earlier regarding map, so it will also applicable in remote sensing data also. So whatever you get from the satellite data, basically we are creating a GIS database out of that, so that can be further used. So that you see the example of satellite data. Now you have a urban area here, and then you have a water bodies also is there, and then different green, whatever is seen, it is a green vegetative. All these things you can upload into GIS. In the GIS, the important thing is you have to first of all know that what is the datum you are going to use, what are the projections you are going to use. So you might have been told, or otherwise if it is not told, we have a special lecture on datums and map projections, so that will be covered later. So those things are also very important. And then before extracting any information from this satellite data, what we do is basically we register the satellite data. So that means give the coordinates and then projection, what type of projection it is. So then that means we are setting the framework for the data, and then once you start drawing the lines or digitizing, so then it will belongs to that particular area, particular location. So and then similarly, when you have something satellite data, suppose if it is a 10 years back, and then if you use a satellite data now, so both the things has to be properly registered, whatever is there earlier and whatever is there in this. So it will come one over the other. Otherwise, suppose if you have something at the sea coast, so some you have digitized as a building. So in other case, if it is not properly done, so it will also go inside the sea. So then you have to see that the proper registration of both the things, giving a exact framework so that these positional things are not misplaced due to the improper registration. So registration and georeferencing is very important component, either in case of remote sensing, also in case of GIS also. So another important thing what I mentioned earlier is global navigation satellite system and its relation to GIS. So nowadays, the GPS instruments, so earlier if you see the old instrument, they used to give only the positional information. So that means wherever I go there, I can record that point, you can store it there or you can manually enter it. So then it used to give latitude, longitude and height information. So nowadays the instruments are also loaded with a GIS packages, so that whatever you collect from the GNSS instruments, it directly goes in the format of a GIS. One is in a shape file or in a raster file or vector file. So you can directly, once you store it, you can also upload that information directly into your earliest GIS layers what you created. So the information is automatically updated. So that means this GNSS instrument, they are also becoming a mobile GIS units. And there are also some softwares are there how to collect a GNSS, how to collect a ground information using a GIS software uploaded into that mobile GIS unit. So the packages like ArcPad is there, one more is there, SuperPad is there, and then there are so many other software like Trimble also they have their own package. So every GNSS instrument they have their own packages, so that it will helps to collect information like a point, line, and area information on the ground. Same thing you can directly add into your further GIS layers. So the same directly can be used for further analysis. So in this, what is generated in the form of this thing directly brought to GIS. Updating of GIS information will be easy and fast using GNS devices. So straight away it is coming. So what I wanted to say that whatever you do using a GNSS or remote sensing or a map, so it is straight away adding to your GIS layer for further analysis. Now you see here you have a E-Tracks, the Garmin, we say GPS, but it is an instrument nowadays. We need not say GPS. It is a GNSS means it can also support GPS. It can support GLONASS. It can also support Galileo. It can support IRNSS. Or there are many these thing. GNSS systems are there. So once the company add those things, so you'll have multiple channels which can help you to get the position. So the number of channels what you get more, so then your positional accuracy also improves. So using this, you can straight away collect the information from the ground directly. So then and then you see there is a map already displayed onto this. If you add some more information, it will be also added to that. So the GNSS instrument also helps to creating a GIS database. Another important component is models. See, we ask children to make models about the earth. Why? Basically, when the children they go to school, they have a little understanding of what is there around the environment. So to give them a real understanding and then to feel them what is that, so we basically make the model so that they can also understand. Suppose if you say earth, so you make it a globe, and then if you wanted to show some satellite or rocket and then ask them to make those smaller models, so and then they can feel that how the satellite or rocket looks like. So it is basically bringing visualizing how it will be in the children's mind. So global warming and climate change, how it see. If you wanted to know that how this global warming is taking place and then how this is affecting the climate change. So for that there are different type of models are there. So people use those models directly, inputting the information like a temperature and all other time series data over the time, and then analyze those things, and how that can be also used the prediction in the future, how it is going to temperature is going to increase, how the crops is going to change or affect this thing, how the ecosystem is going to affect. So these basically, so models plays a role here. The models, for the models, uh, there are different inputs comes. So those inputs, they come in the form of a GIS layers. So that's why when these GIS information is input to the models. So earlier what I was telling is, can you find the changes? Can you find the pattern? Can it is used for the path and then used for navigation? So there, whatever you are asking, so then it is helping you to get some solution. In case of here, GIS is not giving solution, your model is giving solution, but GIS is helping for inputting your layers into this. So finally, if you see, if you want to summarize that, what GIS can do, so GIS can identify something. So there is a well is there, there is a telephone post is there, or it is a post office is there, health center is there. So you can some tourist information is there, India Gate is there, or other monument is there. So all these things you can identify because they are already created and digitized in the map. And then can you also locate? So then you can also locate them where it is located, what is the location coordinates. And another thing, as I mentioned, that optimum path. So it is also, you can use also to find out the optimum path. Optimum path in terms of the distance, in terms of time, and in terms of the cost. So for the cost, suppose if you wanted to have a new route, so in between two places, so then we have to construct such a way that it takes the least cost. So that means it has to go as short as possible, and at the same time it should also not cross many rivers, many wider streams. So it should go cross at the narrow stream, so that bridge and it will cost huge. So even if it is a smaller bridge, but it will cost more than other things. So those things you have to minimize so that cost is reduced. So that is one is the optimum in terms of the cost. Another thing, as I mentioned, if I using a time series data, you can also find out the patterns. So trends is how, what is the trend, it is occurring with the using a different type of sets. As I mentioned also, models. So like children make the models and then satellite models and climate change and then global warming models. So all these things where GIS can help us. So these are the basic components where GIS is going to help us. So and then answering those things like what it is, uh, what is there, like identifying something is what, and then locating something, it is something like a where, and then what is the best route is like these questions are answered through optimum path, and what relations exist, uh, these things. So that is basically the patterns, and then trend is what has been changed from particular one day to another time, and the model is what if condition. So these are the things what we can do in a GIS. So you have to keep these five things, six things what you can do in a GIS. So in summary, if you see that GIS is a integration technology consisting of a remote sensing, cartography, mapping, GPS. Instead of GPS, I can say GNSS, and computers. RDBM is relational database, database management systems, information and communication technology. Nowadays, see everything like you have a Google Earth, you can upload something. So that means the internet is playing an important role here. Survey and field data collection. So all these things plays a role in a GIS. So all are required as part of the creation of something and analysis and further prediction what you wanted to do. So here I have given some questions. So I think you try to think and then send your questions to our this one AView software through chatting. How do you find a place that you are searching for? So this is a question. Give 2 points. Given 2 points with x, y, z coordinates, what will be the distance between both the points? How do you find that distance? Suppose if you have x1, y1, z1, and then x2, y2, z2 are there, then how do you find the distance between both the things? What you will do that and then to get that? How many inputs, images, maps, and GIS layers are required to find the changes? So how many input images, maps, GIS layers are required to find the patterns? What it is called to predict the future scenario. So just now we discussed about a GIS. So what is called to predict the future scenario? Just think of it, and then you just note down or send through chat or answer through that. So I'll just leave a minute here so that then I'll progress. Let us go ahead again. So then what I given is a general understanding of a GIS. So then let us also go to the concepts of GIS. So if you see that GIS means Geographical Information Systems. So let us explain each this thing. What is a geographical and then information system? So geography is the science of Earth's physical features, resources, climate, population, etc. So talking about Earth's feature, what is on the surface and what are its resources, what is the climate and population. So we talk about all these things, it belongs to the GIS, geography. And then geography consists of a geo plus graph. So geo means Earth plus graph means it is something like measurement. So I don't know nowadays this is how relevant it is, but olden days we used to play with this one snakes and ladders. So if two persons are there, they wanted to play this, how the person is going to win fast. So if you get a ladder, you go very fast, but if you get a snake bite and then you come down, so all this thing happens. So it is basically talking about a locational information. So in a GIS also location information plays an important role. So another is information. Suppose if you talk about a satellite data, it comes in a digital numbers. Suppose if you see, so these are all alphabets are given here. So then if you use as it is, so this becomes a data. So there is nothing meaningful information you are able to extract. So but if you arrange this alphabet in a proper order, so then it becomes an information. So that becomes an apple and then dog and cat, etc. So that means we have converted data into an information. So satellite data also we do same thing. So converting that data, digital numbers, into a useful information based on the spectral characteristics and DN values. So we convert on that. So here also A similar way we converted into that. So we can do more of a pictorial representation, the same thing. So the information, it is the apple and dog and this thing. So for children normally when they learn, we instead of writing only this, so we also put a picture so that when these alphabets are there in order and then it becomes to apple, etc. So it's a good way to explain. Now, what is the speciality of GIS? So, to give you example, like earlier I mentioned, suppose we create a land use map with the polygons for different features. So then we used to use a planimeter. So that planimeter to convert into area measurement. So it used to be huge task. So similarly, as I given example of a flooded area and before flood event, suppose you wanted to find the changes. So finding the changes also, it is a Herculean task if you do each independently using the satellite data. So, but if it is done through GIS, it becomes very fast. So that's why GIS basically it facilitates faster processing of operations. Once the database is made, so that database you can use it and then get the information very fast. So, and then if you wanted to use for different application, like I have a particular area, and then I wanted to find out what is the best suitable site for what is that airport area or a certain facility like a site suitability for a dumping ground, a site suitability for a dam, this one, or a reservoir. So for all these things, you use a different type of satellite data, also use the GIS layers, and then you come out with a certain solution. So that means, and then you can also create many scenarios. And then if you talk about the wildlife habitat suitability, then how it is to be done. So, and then you also require continuity of dense forest areas for that. If it is area is reducing or elongation is happening, the proper width is not there. So all these things plays a role for creating a suitability for different purposes. So that means it provides a solution for real-time problems with options of many scenarios. So you can develop in many scenarios. Out of that scenario, you choose the best what is possible. So finally, what is happening is, so same thing, it will helping the people to take the effective decision. So that means it is helping for the decision making process. So with the help of this GIS organized data. So it is also, as I mentioned, it is in summary, as I mentioned here, you use various technologies. So that means you use remote sensing, you use field data, you use a GNSS instrument, you use some maps earlier prepared. So that means all those things we put together. So that's why we call it as an integrated technology. And then dynamic, say nowadays you see Google Earth and all. So and then we have India's Bhuvan. So where they also give you in a 3D information. If you search in the internet, they're also called a street view. So it is something like you are going on a road, and then you can also see that what are the things are there adjacent to the road. Something like what you see when you are physically moving. Suppose you are going into the new place and then you wanted to find out the hotel where you have been booked. So for that, before itself you can realize how this hotel front view looks. And then when you go to that place, if it is a 5 kilometer, 10 kilometer stretch from one place to other place, so all those informations already kept in this GIS interactive environment. So then you can fly through that, something like a virtual roaming of the place you wanted to visit. So all these things is possible in case of in the GIS. Particularly, but first you create a 2D information, then convert into 3D, and then you put it in a fly-through mode, so that you visualize something what you are going to see later. So what are the components of GIS? So the components of GIS is, one is hardware, software, the dataware is the database what you created, and then people who create this. So the expert people who are having a GIS knowledge, and you create that. So that becomes a GIS here. And then, say GIS, if you talk about that, it is started way back 1960s, and then so people coined the word like a geographical information system initially, and then slowly they use many more complex modeling into that, and then he also predicts something what is going to happen in future. So there are a lot of science components are also added, and then people started thinking why it is only limited as a tool. So it should be used as a science to analyze something and then uh, create some different scenarios and then bring in the future components, how it is going to help in the science. So it is also said it is a geographical information. That means people started calling it as information science, and then instead of talking a big words, it is also say combined, people combine it as a geoinformatics. So when you talk about GIS, the same thing, you say geo plus information, it becomes a geoinformatics. So is the terminology used according to the location also. Suppose if you go to Europe and all, so they're more comfortable on the geoinformatics. And then when you talk about some other place like Canada, USA, and all, they call more it in a geomatics. So, geo means the earth, and then matics means measuring. So then the measuring component also comes. So geoinformatics, it comes of like a remote sensing, GIS, GNSS. In geomatics means you also include field survey component, total station, other things, etc. Now, why do you do only on the earth? You can go above the earth and then below the earth. So then it also becomes a spatial information system. Some of the places people use it as a spatial information systems. And then use different technologies used for different applications. So then it will be also called as a geospatial systems. So geospatial information engineering. So when you use for engineering applications, for dam construction, other things, so it is also called a geospatial information engineering. Another is you have land information systems. So you use it particularly for large scale mapping, like a cadastral mapping in urban areas. So it is also called a land information system. So there are various terminologies is used according to the place where they use it, and then for the purpose it is used. So accordingly, the people has given the different terminologies for this. As far as definition is concerned, so it is basically GIS you can define as it is a capturing something. Suppose you capture it through digitization technique, capturing through cameras, capturing through satellite data, and then once you capture it and then you store it, and then you retrieve it, and then you also give a georeferencing coordinates are also added with that, and then you analyze and then displaying which are spatially referenced here. The spatial referencing is very important component in that. So this is a type of a definition. So what we use, basically you capture the spatial information, store it, retrieve it, analyzing and display, which are spatially referenced to the earth. So there are different people have given different type of definitions. One is the toolbox based, the set of the tools. So you say use set of the tools for doing, capturing and showing all these things. You use as a part of a system. it can be a flood information system, or it can be a forest information system, it is urban information system. So use all these things for a particular specific focus. So it is called a system based definition. Another is you have a overall information, like you talk about e-governance and e-services, where all the information, spatial and non-spatial, other things are also stored, and then one component is a GIS. So it is a bigger umbrella of information. So there are three types of set, like based on the tools, what we call define, and based on the system, based on the bigger umbrella of information system. Another is database definition is a database system in which most of the data are spatially indexed and upon which a set of procedures and operations in order to answer queries about the spatial entities in the database. So you create a database with the spatial indexing and then further retrieve it, and then with the queries and then this thing using the database. We use same thing, you store it in a different type of softwares, and then you retrieve the information later on. Another is organizer based definition. So it is also, that's why that definition is decision support system involving injection of the spatially referenced data in a problem solving environment. So this is as far as the definition is concerned. What do you, how its GIS is working in this? See, when you talk about GIS, basically what we do is, suppose if the tree is there on the ground, so that tree information you are incorporating into the GIS. So you say it is stored as a point information. Once you georeference to particular area and the location you digitize as a point information. So then once it is clicked, so it is a point is created with the latitude longitude. So but that is not is a total GIS. So that point we also add some more information like what is it is called a tree, what is the type of tree it is written oak tree, and then height is what is the height of the tree, 15 meters, and then what is the age of the tree. If somebody is having information, you can add other more information also you can add something like what is the volume or what is the dBH, and then how much is the cost of this, and then all this information you can also add. So that becomes a GIS layer point information. Similarly, you can also do for a lines like a roads, canals, and railway line, etc. And then you can also do area features. So that means basically you capture the information and then start recording in a GIS environment. How GIS is working? So GIS is working in terms of the layers. See, if you talk about area, that is a geographical phenomena, that I will talk again tomorrow in detail. So then how this, the photograph or satellite data or the topo map, whatever it is there, and how to extract that information into a meaningful GIS layers. So for that you have to extract into different type of layers. One is like a point information like telephone poles, like as I mentioned, the tree information, or another is a line information like a road network, or it is a area information. So everything, whatever is captured through photograph, that is not a GIS information. It is a one JPEG image. So that JPEG image, suppose later on I wanted to see that whether I wanted to give different conditions. So that is possible only we extract that each information into a different layer. So then I can call back that information later on. So then I can use that for further analysis. For that, we have to digitize, we have to codify, and then we have to give attributes for all this information in terms of different layers, and then I can call back all those things and use it for further query and analysis. So that's why whatever is there on the ground, so I'm extracting into the different type of layers. Once I create into different type of layers, so then I can also, if I have a satellite data, on that satellite data I can also put whatever roads are digitized. I can also put other things, street information. So like that, all these things you can use as a separate layers. One is satellite data, another is a digital terrain model, digital elevation model, and road network, canal information, everything you keep it separately, and whatever way you wanted to integrate, so and keep one over the other, that also is possible in a GIS. So that is the importance of GIS, what you can do. So this is another thing is data model. So this anyhow it will be discussed in detail. What I wanted to say is whatever you extract, like earlier also it is shown that we are showing in terms of layers. So suppose what I wanted to extract from that ground information, I'll do it in particular way. So in a vector format or in a vector data model or it in a raster data model. So vector data model means we will give this thing. What is the coordinates and then string of coordinates. It can be a single coordinate, string of coordinate, and then in a area mode also we do it with their coordinate for each point wherever you record, and then that will be stored with the coordinates and then directions. So that will be stored as in vector data model. Another is you put a mesh grid on that, and then that mesh grid, and then each square whatever is coming on the ground, so that you store it. So that means you converting the whole area into small pixel elements. So that pixel element you store it, and then that pixel element you can further use it, further analysis, etc. So whatever way you store it, so that becomes a particular data model. So that's why we do it in a raster and vector data model. So this will be further discussed in the further lectures, separate lectures also there in that. So nowadays there are different type of GIS. Suppose as I give an example, like earlier I go to the field and collect the data. So like using a GPS instrument, that is called a mobile GIS. Suppose I have everything and then I am started digitizing as an independent, but I am not connected to anything. So that is a independent system what I am working. So it is called a desktop GIS. So even desktop PC, what you use a PC earlier, it is also we mentioned. Same thing, desktop PC is used for a GIS. So then it is called a desktop GIS. And then you have many components are there in a GIS. Like for a particular analysis, vector analysis, raster analysis, grid analysis, network analysis. So there are many components. So if you have all these components together in a GIS, so then we call it as a professional GIS. And then enterprise GIS is particularly using for commercial purposes for big projects. So that is called commercial GPS. And then suppose I wanted to visualize, like as I mentioned earlier, street view. So it works in an internet environment. And then Google Earth, if you take, I wanted to go from one place to another place, you ask that Google Earth to visualize, so then it will fly through that area. And then nowadays we also use internet for finding the places. So either in the form of a map, in the form of a satellite, in the form of a 3D view, all those things you can do these things. That is called Internet GIS, which is basically finding something and locating something and then visualizing something. So all those things you can do it, but for that somebody could have been created that earlier, so that you can use it. So that is called Internet GIS. So there is a embedded GIS. Embedded GIS is as part of different other package, you also incorporate a GIS. Suppose if you talk about your Word, Microsoft, so then you integrate your textual information and then your GIS layer information and then presentation information all together, then it becoming incorporating a GIS into that. Suppose if you talk about a notepad, or if you talk about a Microsoft Word, not this thing, but as part of the Windows, so there you don't have many components like a graphical tools. So that, but when it comes to Windows and PPTC, the graphical tools also incorporated and embedded into that. So there is also called Microsoft they also brought out PowerPoint is one thing, that's for some presentation. Another is Map Point. So Map Point is something they brought into Microsoft Office environment. So that means if you're doing business, so integrating all this textual and presentation graphics tools and then spatial components together, so that Map Point is also works similar to that. So that means something like you embedding GIS component into as part of the total enterprise solutions. 4D GIS, suppose I wanted to visualize something, how the flood is going to inundate the area. So that you can model it. One is the three-dimensional information as well as the time component. Over the time, how it is going to flood. Something like a tsunami, if you wanted to predict the tsunami, suppose there is an earthquake in the deep sea, and then once the plates are uplifted, how the water is going to force into the shore, and then that how do you visualize that, how much time it takes. So all those things can be done in a 4D GIS. Similarly, like a cyclonic storm, if it has started somewhere and reaching the coast and how it is going to devastating the whole area, so that can be done in a 4D GIS. Multimedia GIS is a GIS, you also add audio, video, and then text into that, so that becomes a multimedia GIS. As part of a GIS, so you have many analyses what we can do. So like as I mentioned, I wanted to see something, the simple query is enough. So spatial, one is you query the database, like a Excel sheet or database what we use to query and find out somebody's name and then what is his address, etc. So there you don't require a spatial component. But if you wanted to see, locate somebody whose address, geocoding or his own address, so then you have to see the name, person's name, and then where his address is located on the spatially. So that we call a spatial. And single layer query is, one is identifying and locating, as I mentioned like that earlier, in a GIS what you can do and all, and the optimum route, etc. That is a single layer operation. And then multi-layer operation is, if you wanted to find different changes and patterns, you have to use multi-layer operation. Spatial modeling is something if you wanted to do climate change and then what is the future scenario. So the spatial modeling is a surface analysis. Suppose you wanted to find out what is the surface runoff, how it is going to happen based on the different rainfall conditions. So that is called a surface analysis. So you can also think of a flood modeling and somewhere fire is happening and then how the fire is progressing over the time because of the wind speed and other things. So these are all called a surface analysis. Network analysis is something like a finding optimum route. Uh, route and then finding what is that road network and finding the route. So that is called a network analysis. We have a special lectures, all this and different type of analysis. One is a vector analysis, spatial analysis. Even there is also lecture later we also deal in detail. So that is called a network analysis. So in that part of analysis, we will also discuss about a point pattern. Different points are there in a groundwater condition, as I mentioned earlier. How to use that groundwater points, locations to interpolate a map, that is called or a rainfall points, how to interpolate specially. And a grid analysis is something like a using raster data used for different applications. So watershed analysis or any raster based analysis, we do it in a grid analysis. So these are the different type of analysis. So as far as applications are concerned, I divided into different type of applications, like a natural resource management, like a forest inventory, and then forest density, and then you talk about agriculture, crop irrigation, and then you talk about geological maps, and then mineral resources. All these things, different type of applications. Infrastructure development is like a highway infrastructure, and we talk about airports and road network and then railway network. So this all comes under a pipeline between two places to transport even the oil. Like we have a lot of ambition that bring that oil from Iran to India directly via Pakistan. So these are all infrastructure development. Utility services like a public health centers were all located, and then water pipeline network, how those pipeline networks are used for supplying the water. So these are all utility services. And then business applications, like if you wanted to identify a particular place which is good for a particular type of a business. Suppose you wanted to have a some different type of store, and then how it is going to give the potential or good profit to the particular person. So these are all business type of applications. Another is investigation services. Suppose what are the types of crime is happening and what is the pattern of that crime, and what are the sources for this crime. So that is all comes under a investigation type of services. Another is e-governance, means there is a government support creating the spatial information, how the spatial information is used by different people, and then spatially whatever is there, and then done through the government, providing a different utility services or as part of the payment, or if you talk about cadastral information and land information systems, and then how it is used, the property tax collection. So that is also comes under the e-governance. So these are the some of the applications. There are so many n number of applications you can still think of. And then if you talk about GIS development in national these things, so it is done at various levels. If you talk about the GIS, it used to be limit only research organizations and some of the limited organizations initially, like a DOS, ISRO, NRDMS, DST, NIC, TCPO, like that it has started, but now the number has increased many. And then there are each state there is a state remote sensing centers, and then science and technology department, NGOs. So now recently the government also has come out with an idea why all the departments, all the government departments, private departments and state government departments, why they don't use potential of this one space technology. So that's why we also have a national meet, and further emphasizing that the big potential of the remote sensing GIS, and then it should be used at various departments. So if you come to private, there are many private organizations. In India itself, there will be around 500 or more than that type of organizations are there. When you talk about software and hardware, as I mentioned earlier, it used to be a proprietary software initially. Anybody wanted to use a GIS, it used to be a huge cost. So, but last, if you say 5 to 10 years, so the trend has been shifted. Instead of only proprietary software, so then we started using open source software. So there is also called OpenGeo. So the portal is there where a lot of softwares are developed for different applications. So then you should use that type of softwares for different this thing. And then there are also free softwares. So free softwares may be open source or maybe proprietary software. So in case of proprietary software, they are making free. If the software is becoming old, so then they think that there is no more charging people who may not pay. So they say they make it free. So that's why if you wanted to use a GIS, so the GIS can be without any cost also you can start using it. So there are free softwares also listed here, ILVIS, GRASS, Quantum GIS, etc. In our case, we are also more emphasis will be given to Quantum GIS, so that is open source, and then you are all learning from your own side where you don't have a commercial software, so then it becomes for you, all of you, to use this open source software. I don't know how many of you know him. He is called father of GIS. His name is Roger Tomlinson. So I think he was there till 2011 or something, but now he's expired. So he's the person who coined the word GIS, Geographical Information System. So if you see that overall growth of GIS, it started in 1963. The same thing, Roger Tomlinson, he established Canadian Geographic Information Systems, basically creating the national land inventory. That was the beginning. So similarly, Harvard Lab, it was meant for the visualization, graphic tools, etc. So another is SciMap, which is sinographic mapping, and then more developments more towards North America and to a certain extent Europe. So developments in Asia and other countries, it was not that much when you talk about earlier development. So, and then if you talk about GIS software, etc., you see that Israel launched ArcGIS in 1981, and then GRASS 85, MapInfo 86. So everything is almost happening in 80 to 90. So that time only, but by after 1995 only it has picked up. So because many people have started also developing, and then beyond this is now people are talking of internet GIS, mobile GIS. So now of more of a smartphones. So that now I don't know how far we go, But now everything is coming in the smartphones with mobile mapping capability, and then GPS also integrated in that, so that it help you to straight away acquire information. It is called a mobile GIS. Straight away you collect some information on the ground and then send it to the website. That is more of a internet GIS. With this, I end my lecture. So, as far as this one CEO of ESRI is Dangerman, he says that application of GIS is limited only by the imagination of those who use it. So there is no bounds. So anybody started using, you have tremendous potential in this. So it's a lot of potential which can be realized, and then you can also come out with the innovative ideas how we can start the new things. So thank you all.